Thank you very much. I excuse I'm not very good at talking while sitting, so I'm glad to be here on this side. Just a slight background. My affiliation is with University of Porto, a teaching affiliation, but my location is at the Research Institute, where we do have a research unit on neurogenetics, but also provide genetic services, both in terms of genetic testing, counseling, and education in general. So these are the 5 points that I will try very briefly to discuss. This is the reason why we are discussing all this. And there are two main points that I would like to clarify. One is the potential for high throughput from these new technologies, and the other one is decreasing of costs. And while the second one, decreasing of costs, will have an impact both for research and for diagnosis, the high throughput will have only in some contexts. So that's a difference that we must keep in mind. We should never begin talking about anything without clarifying definitions. This is following a work done for Eurogen tests. There are many differences that we can still find in the policy paper that need some clarification, namely PGD versus PGS, but I'll come back to this in a moment or in discussion. And we also need to clarify if we are talking about patients and clients or consumers and what the distinctions are. So this is some of the differences that I would like to highlight. Is the difference between genetic information and genetic testing, because it's not the methodology that counts, it's content that we can derive from it. So this should be content-driven and not methodology-driven. And genetic information comes from other sources, other than genetic testing, from family history, physical examination, other laboratory tests, and so on. Also, among the medical applications, not everything is clinical genetics. We have biomedical research, we have public health genetics in the traditional sense, which is not is not in the setting of clinical genetics, where there is a clear distinction between diagnosis and counseling, and here between affected persons, diagnostic testing, and healthy people for predictive testing. And this is a very important distinction to make. Something I think is very relevant to the tensions that we have been seeing, and we can feel it from reading the documents, the tensions from two different paradigms. The one on one side, the one from medical genetics and genetic counseling, which is centered on individual, is centered on the family. Our patients are the families. While on the other hand, we have public health, which is centered on the public good and the health at the population level. And this, of course, has to do with these tensions that have already been mentioned as well. We have distinguished clearly what we mean by genetics and genomics, and that's one important distinction in medical genetics and genomic medicine. And sometimes we have a field that has those. There are some specificities. We are largely talking about a common field with a lot of overlapping, but giving it different names and even having different journals. The scope until now used to be for diagnostic services, a targeted testing in a stepwise. So you test this gene, this mutation, if not, you'll go to the next one, and so on. But as we have seen, this will be largely filled in, though not completely, by next generation sequencing, preferably through gene panels for targeted diagnostic testing, but also we see that it's already there, whole genome and genome sequencing for clinical applications, and that's what we really have to discuss. I think I will skip this slide. And to mention some very basic rules about consent. Everybody knows this, but I think it's still important to say that consent is a process, not a term to sign. Without proper, adequate, full information, there is no informed consent. that consent is to protect patients or research subjects, not a disclaimer of the physician or researcher responsibilities. On the other hand, for informed consent, we need all necessary unbiased, meaning prejudice-free information for a good decision and free decision-making process, to make sure that this information has been understood, and that requires time, and that requires opportunity for questions and doubts, and it requires that both the patient or participant, the doctor and the researcher sign the term in duplicate, and the duplicate is delivered to each one, which is not still the case in many places. So just a reminder of the importance of this. And there are barriers, of course, to proper consent that are coming from pressures from different sides, from physicians, third parties, prejudice, as I said before, lack of time, lack of information, or too much information may be also a barrier to proper consent, and sometimes including unduly wrongful writing. In terms of context, we need, and that's really a statement, I think it's an important one, we need a separate consent for medical care and for research. By this meaning, that I truly believe that information from this research should not be disclosed to participants unless after validation in a clinical diagnostic setting and after quality, and after counseling, and this is really a quality issue in itself. And consent should at the same time promote data sharing and research while protecting participants and not becoming a barrier in itself, as we have heard before. We have heard also before the need to harmonize when there is a large flow of large information over borders, so I will skip this. Individual consent. When we're dealing with genetic information, we must remember that it has implications for relatives and for family members as well. But in some instances, we do have minors and vulnerable persons, but when we are dealing with population genetics, or with large quantities, with biobank studies, we come at the population level, and sometimes we have vulnerable populations. We need consent of the community, of the world population level as well. And we must remember that sharing is not only sharing of data, it's also sharing, may also imply sharing of benefits. This should even at capacity level building, and this must be, of course, be incorporated in the consent process from the beginning. Two different contexts, I think, have different implications, and are just examples to different situations. In newborn genetic screening, genetic counseling is done only afterwards if something is found, but consent should be sought beforehand anyway. In preconception screening, we are much closer to the medical genetics paradigm than to the public health genetics paradigm as in the first case. So we can and should precede it by genetic counseling to the couple seeking reproductive counseling. Blurring frontiers, we have been hearing about this a lot. I just want to remind one more, I won't repeat the others, but the blurring frontier between diagnostic and predict genetic information. If next generation sequencing is used for diagnostic purpose, it will deliver not just diagnostic information relevant for the present clinical situation, but also predictive information for the future of that person. Between diagnosis and screening. Another blurring frontier is between genetic databases and biobanks. Once we have the whole genome sequence, we don't need the biological material anymore. And so all the situations of the accumulation of the material and so on, that the ethical problems related to it will be turned into the genetic databases anyway. But even so, if the costs are going down, and that's one of the statements that is done, that it can be kept for future use. But if it's going to be very difficult to accumulate and to build such a heavy structure. But if the costs are going down the way they are, it might become cheaper to redo the sequencing than to accumulate that and keep that information that will maybe more costly. Again, this has been said before, irreversible anonymization is no longer possible now that each genome is unique and then traceable. The hyper-analytical and clinically unvalidated genetic variants, and the very complex consent process in this context. Some centers do use complex, like in the Netherlands, complex decision trees and algorithms for decision-making process and for consent process in terms when using next-generation sequencing, something that must be well discussed. I think that I will also skip this one. The main thing here is that consent must be context dependent then, and must always be done prior to data collection, sampling, and not before. We are all aware of the differences between the recommendations of the American College and those of the European Society. I'm not going through them, just remember that one of them, the European Society, is to build guidelines for informed consent, something that we really need very much. And I will use this as a new model that really has been set up recently after all the controversy of the sequencing of the genome of Henrietta Lacks, whereas the NIH researchers decided, together with the family, to build a committee that would endorse case-by-case information, and this committee will include family members. So this is a new model, and it sets a new model for a consent process, which I think is very important. Finally, and this is, I'm just closing, cannot forget education of all different publics, and to involve the wider society in these debates. The additional protocol of the Council of Europe that we'll be hearing further on is a very important piece of recommendations that we must take in consideration if we really want to attain this statement, the larger statement of effective and responsible translation of genome-based knowledge and technologies for the benefit of the population health. It might be a long and winding road, but I think it's worthwhile going through it. And I just finished by acknowledging this picture I used in the beginning by a Portuguese artist. It's one of a series that is precisely called Henrietta Lacks. Thank you very much.